हेलो बच्चों, आज हम लोग लॉस ऑफ काइनेटिक एनर्जी इन इनएलास्टिक कॉलिजन का अध्ययन करेंगे। इसमें हम लोग इनएलास्टिक कॉलिजन के दौरान हुए गतिज ऊर्जा में ह्रास के लिए एक्सप्रेशन प्राप्त करेंगे। लेट two bodies of mass m1 and m2 having velocities u1 and u2 undergoes inelastic collision in one dimension। दो वस्तु m1 एंड m2 है जिसका वेलोसिटी u1 एंड u2 है, वन डायमेंशनली कोलाइड करते हैं और कॉलिजन के उपरांत उसके वेग v1 और v2 हो जाते हैं। तो इस v1 और v2 को हम लोग पहले कैलकुलेट कर चुके हैं, यहाँ पर सिर्फ उसके रिजल्ट का उपयोग कर रहे हैं। v1 इजकल टू m1 माइनस ई m2 प्लस 1 प्लस ई m2 u2 बाय m1 प्लस m2। v2 इजकल टू m2 माइनस ई m1 प्लस 1 प्लस ई m1 u1 बाय m1 m2। अब हम लोग कॉलिजन के पहले और कॉलिजन के बाद का काइनेटिक एनर्जी ज्ञात करेंगे। काइनेटिक एनर्जी of two bodies before collision. Before collision, their velocities are u1 and u2. So kinetic energy is half mu m1 u1 square plus half m2 u2 square. And kinetic energy of the two bodies after collision is equal to half m1 v1 square plus half m2 v2 square. Then loss in kinetic energy during collision is equal to delta t, kinetic energy before collision minus kinetic energy after collision. Delta t is equal to half m1 u1 square plus half m2 u2 square minus half m1 v1 square plus half m2 v2 square. Taking common 1 by 2 from each term, we get delta t is equal to half m1 u1 square plus m2 u2 square minus m1 v1 square plus m2 v2 square, bracket closed. This is equation 1. Now multiplying and dividing above equation 1 by m1 plus m2, we get delta t is equal to m1 plus m2 by 2 m1 plus m2, bracket under m1 u1 square plus m2 u2 square minus m1 v1 square plus m2 v2 square. Or delta t is equal to 1 by 2 m1 plus m2. m1 plus m2 is multiplied separately in bracket under terms m1 plus m2 m1 u1 square plus m2 u2 square minus m1 plus m2 m1 v1 square plus m2 v2 square. To obtain delta t, we should have to evaluate two terms of equation 2. First term is m1 plus m2 into m1 u1 square plus m2 u2 square. Multiplying on, we get m1 square u1 square plus m1 m2 u2 square plus m1 m2 u1 square plus m2 square plus u2 square. Taking common m1 m2 m1 m2 and m1 m2 and rewriting, we get m1 square u1 square plus m2 square u2 square plus m1 m2 u1 square plus u2 square. Now adding and subtracting 2m1 m2 u1 u2 in above equation. We have m1 square u1 square m2 square u2 square plus 2m1 m2 u1 u2 plus m1 m2 u1 square plus u2 square minus 2m1 m2 u1 u2. Again, this term is form of a plus b whole square, and m1 and m2 in this term we can take common, and then we rewrite m1 u1 plus m2 u2 whole square plus m1 m2 into u1 square plus u2 square minus 2 u1 u2. This term also in the form of a minus b whole square. Then now here rewrite m1 u1 plus m2 u2 whole square plus m1 m2 into u1 minus u2 whole square. Now the first term becomes m1 plus m2 m1 u1 square plus m2 u2 square is equal to m1 u1 plus m2 u2 whole square plus m1 m2 u1 minus u2 whole square. Equation 3. Second term, we get second term is equal to m1 plus m2 into m1 v1 square plus m2 v2 square. On multiplying, we get m1 square v1 square plus m1 m2 v2 square plus m1 m2 v1 square plus m2 square v2 square. Now again taking common m1 and m2, we get m1 square v1 square plus m2 square v2 square plus m1 m2 v1 plus v2 square, v1 square plus v2 square. Now adding and subtracting 2m1 m2 v1 v2 as we have done previously, we get m1 square v1 square plus m2 square v2 square plus 2m1 m2 v1 v2 plus m1 m2 v1 square plus v2 square minus 2m1 m2 v1 v2. This is the form of a plus b ka whole square, and second in this portion we can get a minus b ka whole square, which is m1 v1 plus m2 v2 ka whole square plus m1 m2 into v1 minus v2 ka whole square. Equation 4. Now we have coefficient of restitution is equal to E is equal to V2 minus V1, U1 minus U2. We can write it V2 minus V1 is equal to E, U1 minus U2. Now squaring, we get V2 minus V1 whole square, E square into U1 minus U2 whole square. From law of conservation of momentum, we have m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Equation 6. Now using equation 5 and 6 in equation 4. We have m1 plus m2 m1 v1 square plus m2 v2 square is equal to m1 u1 plus m2 u2 whole square plus e square m1 m2 u1 minus u2 whole square. This is equation 7. Now using equation 7 3 in equation 2, we have 7 3 delta t is equal to 1 by 2 m1 plus m2 m1 u1 plus m2 u2 whole square plus m1 m2 u1 minus u2 whole square minus m1 u1 plus m2 u2 whole square minus e square m1 m2 u1 minus u2 whole square. Now delta t m1 u1 plus m2 u2 and minus m1 u1 plus m2 u2 cancel out, and we get delta t is equal to 1 by 2 m1 plus m2 m1 m2 u1 minus u2 whole square 1 minus e square. Delta t is equal to 1 minus e square m1 m2 u1 minus u2 whole square by 2 m1 plus m2. This equation gives loss of kinetic energy during inelastic collision. यह इक्वेशन जो है इनएलास्टिक कोलिजन के दौरान हुए गतिज ऊर्जा में ह्रास को प्रकट करती है. अब केस 1, जब कोलिजन पूर्णतः इलास्टिक हो तब E इज इक्वल टू 1 होता है. तब द expression of lost kinetic energy gives 1 minus 1 m1 m2 u1 minus u2 whole square. Here in the position of, it is the position of E square, where we have put E is equal to 1. Then 1 minus 1 is equal to 0, and in elastic collision the total loss of energy is 0. In case 2, when collision is perfectly inelastic, then E is equal to 0. When E is equal to 0, E square is equal to 0. 1 minus 0 square m1 m2 u1 minus u2 whole square. Thus m1 by m1 m2 u1 minus u2 whole square by 2 m1 plus m2. Again, when target is at rest, means m2 is at rest, u2 is equal to 0. Thus loss in kinetic energy is equal to m1 m2 u1 minus 0 whole square by 2 m1 plus m2, or delta T is equal to m1 m2 u1 square by 2 m1 plus m2। अब आज हम लोगों ने इनएलास्टिक कॉलिजन के दौरान हुए गतिज ऊर्जा का ह्रास के लिए एक्सप्रेशन प्राप्त कर लिया। स्टूडेंट्स से मेरी एक एडवाइस है कि वे इसको लिखते हुए, विभिन्न इक्वेशनों को लिखते हुए प्रैक्टिस करते हुए समझें, तभी समझ पाएंगे।